In example 5, we have another triangle to solve. It's called SFT, and we have little f, little t, and capital T. And because of the name of the triangle, I know that, I don't know much about it, but I know that SFT form that order, and little f has to be opposite of little capital F. So we're going to put our 56.78 over there, and then little t across from capital T, we're going to put a 56.78 over here. And then angle T, we're given that is 83.78 degrees. So let's try to solve this triangle. Okay, so I have a pair with T, and I have one of F's components, so I'm going to find capital F angle first. So I'm looking for an angle. I'm going to put the sign of F on top. So the sign of F over little f, 56.78, equals the sine of T, 83.78, over 56.78. Multiply this over, and that will give us the sine of F. So we are multiplying a 56.78 over. Coincidentally, in this one, since those two measures are the same, it looks like these are going to cancel, and I'm going to get sine of F equals sine of 83.78. Now, that doesn't mean that F is 83.78, but it's one of our choices because the sine and arc sines are going to cancel off. But there's another choice right here because there's more than one angle that has the same sine value. And so I want the 80 degree, and I also want the one that has a reference angle of 80 degrees. So I got to find both of those. So one of the choices for F is that F is 83.78 degrees. Or the other choice for F is that F is just shy of 180 by that much. So 180 minus 83.78 degrees, which is 96.22 degrees. Okay, so those are the two possibilities for F. And so based on those two possibilities, we'll be able to construct two paths up here. Okay, so the first one is going to have an F value of 83.78 degrees. The second one's going to have an F value of 96.22 degrees. Okay, so angle S is one that I don't yet know, so let's find angle S. So it is 180 degrees minus angle F minus angle T. So if we take 180 degrees minus angle F as 83.78 degrees minus angle T as another 83.78 degrees, this gives us an angle S of 12.44 degrees. And if we try this again, but we're subtracting F being 96.22 degrees, this gives us an S value of 0. Now, if S is 0, this is not a triangle. So we can't have a triangle with 0 degrees, and so this triangle cannot exist. It's just a line. So we're not going to get two answers here. We're going to get just one. Unlike the last example that we did where we got the two possibilities. We don't get two here. This one doesn't work. So a negative angle or an angle of 0 is an indication that that's not finding a valid triangle. Okay. So now let's find the thing that we are missing. We are missing side little s. So we're going to put our sides on top. And so we'll have little s over sine of 12.44 degrees equals the pair that we were given, 56.78 over sine 83.78 degrees. Multiply the sine of 12 over and we'll get little s. So little s is sine of 12.44 degrees times 56.78 divided by sine 83.78 degrees. And so I get a measure for little s of 12.304 meters. I actually had a unit on there. Hopefully I didn't have one in the last couple. I didn't note that I had a unit. Oh, I did. Cool. This one was in kilometers, so I could make this even better by putting some kilometers after those. Just didn't notice my unit because I didn't have one in the top one for sure. Okay, so we got some meters. And that solves the triangle because I found the three things that were missing. I found angle F, angle S, and side little s. There's only one possibility. All right, let's take a look at example 6. The not so stables needs to make a temporary horse pen with some rope. They've got 30 feet of rope and plan to tie the rope from one corner of a barn, go around a tree, and then back to the other corner of a barn. So the tree is 21 feet from where the rope is first tied, and then the rope to the tree makes an angle of 35 degrees with the barn. Do they have enough rope if they allow for 5 feet of rope to properly tie off the ends? So since they're allowing for 5 feet to tie, that means that instead of having 34 feet, they really only have 29 feet to work with. So we'll just shorten the available rope right away to 29 feet of rope to work with. Okay, so that's already been 21 of the feet. Can they get the to side Q with only 8 feet? Let's find out. So we need to solve for that side and see if they can get there in 8 feet. Okay. Okay, so let's see. I'm going to put 8 right here on this side because I need a pair. I don't know how big the barn is. That's going to come into our check on this. But I need a pair. If they had just told me how big the barn was, that would also be helpful. But instead, we'll check the other way. I have a pair now of little s, big S. And what I need to find now is actually little t to know if this is going to be barn-sized or not. So first, I would need to find angle t, but I can't find angle t because I know nothing about t, so I need to find angle q first. So that's where we're going to start. So I want an angle, so we'll set up with the q on top. Sine of q over 21 equals sine of 35 degrees over 8. That means sine of q is equal to 21 times sine of 35 degrees over 8. And so if we just calculate that ratio, 21 times the sine of 35 divided by 8 is 1 point. Ooh, interesting. So that gives me sine of q equals 1.506. If I go to find q, I will take the arc sine on both sides. Q equals the arc sine of 1.506, but it's not going to work because if you recall, the range of sine is -1 to 1, and this is too big. So that's not possible for sine. So this is definitely too large. Sine can only output values that are below 1. And so this triangle has no solution. Basically, they don't have enough rope. So with only 8 feet, it's not possible to make that with a 35-degree angle.